Sixth question is design Verilog program to implement different types of multiplexer like 2 is to 1, 4 is to 1 and 8 is to 1. First is 8 is to 1. Eight input lines, D0 up to D8. Output line Y. Select lines are 3. 1, 2, 3. S, S0, S1, S2. 8 is to 1. This is the block diagram of 8 is to 1. Let's see the program of modulo mux SDY. Input is 2 is to 0, input is 7 is to 0, D, output by register by always at S or D, case yes. 0 is to y is equal to D0, 1 is to y is equal to D1, 2 is to y is equal to D2, 3 is to y is equal to D3, 4 is to y is equal to D4, 5 is to y is equal to D5, 6 is to y is equal to D6, 7 is to y is equal to D7, hand case, hand module. Next is 4 is to 1 multiplexer. Here 4 input, 1 output to select line, 4 is to 1. Here D0, D1, D2, D3. Output of Y. Select lines are S0, S1. This is the block diagram of 4 is to 1. Let's see the program of 4 is to 1 multiplexer. The modulo function mux SD input y is the output. Input 1 is to 0 has input 3 is to 0 D, output y register y. Always at S or D, the case has 0 is to y is equal to D0, 1 is to y is equal to D1, 2 is to y is equal to D2, 3 is to y is equal to D3, end case, end module. The next is 2 is to 1. Here 2 is to 1 multiplex. So 2 input D0, D1, 1 select line S0, 1 output Y. This is the block diagram of 2 is to 1. Let's see the program of 2 is to 1. Modulo mux function to variable 1 Output input 0 is to 0 has input 1 is to 0 D. Output Y register storing of value Y always at S or D case S. 0 is to Y is equal to D0, 1 is to Y is equal to D1. End case, end module. Here the output of this multiplexer 2 is to 1 multiplexer, 4 is to 1 multiplexer, 8 is to 1 multiplexer.